Hello everyone. I'm going to talk about Mathematics Olympiad today. This video is about Mathematics Olympiad. Mathematics Olympiad is an exciting challenge that many math-loving students are eager to engage in. At the beginning, at first, it may seem daunting. It becomes more approachable if you have a clear understanding of the fundamental principle of mathematics and how they apply to different problems. Most of the questions in Mathematics Olympiad contain hidden strategies or patterns that you have already learned in your classroom, in theory. The key is to uncover them through critical thinking. Your main task is to unearth these solutions by connecting the dots. This requires not only solid foundation but also continuous practice. So practice is more important. The more you practice, the better you become at spotting these patterns and solving complex problems with ease. Participation in the Mathematics Olympiad doesn't just test your knowledge, it sharpens your logical thinking, creativity, and perseverance. Every problem you solve builds your confidence, and every challenge you face makes you a better problem solver. So don't be afraid of the complexity. Embrace it with curiosity and persistence because every solution is within your reach. Today, I'm excited to tackle 2 or 3 common Mathematics Olympiad questions with you. These problems will give us a glimpse into the types of challenges maths enthusiasts like you and I love to explore. I hope you will join me on this journey as I continue to dive deeper into the fascinating world of mathematics. Together, we can unlock new strategies and sharpen our problem solving skills. If you enjoy this, please subscribe to stay updated on future content and join me in this adventure. I'm going to start my first Mathematics Olympiad question, that is to find the 12th power of 1 plus square root of 5 divided by 2 using. Now you can solve this problem by expanding the 12th power of 1 plus root 5 divided by 2 using the binomial theorem. However, this approach involves complex calculation, especially when dealing with powers of the square root of 5. To simplify, I will focus on using only the expansion like a plus b to the power 2 and avoid more complicated calculation involving the square root of 5. This method is more manageable and will help streamline the process. So this is how I do this one. Say I will take x as 1 plus square root of 5 divided by 2. So why I'm doing this way? Because if I look at this 1 plus square root of 5 divided by 2, I can see that it is a solution of a quadratic equation. So now I am going to find what quadratic equation is that one. For that one, I will multiply both sides by 2, that is 2x is equal 1 plus square root of 5. Then I can write 2x minus 1 is equal square root of 5. Okay, now if I square the both sides, then I can get rid of that square root of 5. So I will get the square of 2x minus 1 square is equal square root of 5 square, that is equal, if I expand this one, it is equal to 4x square minus 4x minus 1 is equal to 5. Sorry, this one is plus 1. Okay, now if I subtract 5 from both sides, I will have 4x square minus 4x plus 1 minus 5 is equal to 0. Then this is equal to 4x square minus 4x minus 4 is equal to 0. Now you can see that you can get rid of this 4 dividing both sides by 4. That is x square minus x minus 1 is equal to 0. This is equal, x square is equal x minus 1. So now x square minus x minus 1 is equal 0 is the quadratic equation. Now I can see that x square is always equal to x minus 1. X plus 1. Okay, now let's go to 1 plus root 5 to the power 1 plus root pi divided by 2 to the power 12 mean x to the power 12. What I want to find here is x to the power 12. X to the power 12. Now x to the power 12 I can write as x to the power 2 to the power 6. Okay, now I found that x square is x plus 1. I will write this one as a. So then from a I can write that x square is equal to 1 plus x then to the power 6. Now according to the index law, 1 plus x to the power 6, I can write 1 plus x to the power 2 to the power 3. One plus x to the power 2 to the power 3. So this is equal, I can expand 1 plus x square, that is 1 plus 2x plus x square to the power 3. Now again from x square mean 1 plus x. 1 plus 2x plus x square is x plus 1 to the power 3. So this is equal 1 plus 3x plus 1 to the power 3, that is equal 3x plus 2 to the power 3. Okay, now you have 3x plus 2 to the power 3. Now I can write this 3x plus 2 to the power 3. I can write 3x plus 2 to the power square times 3x plus 2. That is also index law. This is, I can write this way. Now this one I can simplify. 3x plus 2 square, I can expand this one. Then this is equal 9x square plus 12x plus 4 times 3x plus 2. Then again I can write 9 x square is from a, I can write x plus 1 plus 12x plus 4 plus 3x plus 2. So this is equal 9x plus 9 plus 12x plus 4 times 3x plus 2. So this is equal 9x plus 12 is x is 21x plus 9 plus 4 is 13 times 3x plus 2. Now we can expand this one, that is simple binomial expansion. So 21x times 3x is 63x square plus 20x plus times 2 is 42x plus 3 times 13 is 39x plus 13 times 2 is 26. So now I can simplify that one. 63x square plus 42x plus 39x is 81x plus 26. So again from A, x square means x plus 1. So plus 81x plus 26. Now you can simplify that one. 63x plus 63 plus 81x plus 26. Now this is equal 63 plus 81 is 144x plus 63 plus 26 is 89. Plus 26 is 89. This one plus this one is 89. So now we know that x is 1 plus square root of 5 divided by 2. So now I can substitute this one. 144 times x is 1 plus square root of 5 divided by 2 plus 89. Now you can cancel 2 and that is 72. So 72 times 1 plus square root of 5 plus 89. So this one is 72 plus 72 square root of 5 plus 89. So this is equal 72 times 89 is 161 plus 72 square root of 5. So this is the answer. 1 plus square root of 5 divided by 2 to the power 12 is 161 plus 72 root 5. So you can see that I did not expand any square root of 5 or I did not get any higher powers of square root of 5. So I just simply use x equal 1 plus square root of 5 divided by 2. That's okay. Now let's go to the second question. That is to solve 8 to the power x plus 2 to the power x equal to 130. So at first glance, this equation may seem like a simple equation, but it is more complex because the exponent is a pronumeral and the base are not the same, which adds to the difficulty. However, if you look closely, you will notice an important detail, that is 8 is actually the cube of 2. This observation provides a crucial clue. By expressing 8 as 2 to the power 3, you can rewrite the equation in terms of a common base, making it easier to solve. That is, that 8 is 2 to the power 3, then x plus 2 to the power x equal to 130. Now, we know that in index law, a to the power n is equal a to the power n m. So therefore, 2 to the power 3x I can write as 2 to the power x to the power 3 plus 2 to the power x equal 130. So I can simplify that one, 2 to the power x to the power 3 plus 2 to the power x minus 130. Okay, now it is now looks like a simple equation. So what I do, I will write, let x be 2 to the power x. Then I can rewrite this equation. 2 to the power x is now x, capital X to the power 3 plus x minus 130 is equal to 0. Now it is very clear that this is a polynomial of degree 3. So you can use the trial and error method to find the initial value of x, but it is a little bit difficult, time consuming. So what I do, I can write that x mean 1x. So I can split this into 25x and 26x minus 130 is equal to 0. What I did, instead of x, 1x, I wrote minus 25x plus 26x. So now I can write it again here, x to the power 3 minus 25x plus 26x minus 130 is equal to 0. Now, I can factorize them separately. That is x common here. Then you have x square minus 25 plus 26 is common for this one. That is x minus 5 is equal 0, because 26 times 5 is 130. Therefore, 130 is divisible by 26. Now, x square minus 25 is a 5 square. X square minus 5 square plus 26 times x minus 5 is equal to 0. Now, we know that a square minus b square factors are a minus b, a plus b. So, this one x square minus 5 square is difference of 2 squares. So, therefore, factors are x minus 5, x plus 5 plus 26 x minus 5 is equal to 0. Now, you can see that x minus 5 is common to both terms. Then I can take x minus 5 outside. Then you have x plus 5 plus 26 equal to 0. Okay, now I can expand the big bracket, this one. It is x square plus 5x plus 26 is equal to 0. Okay. So now what I have now, x minus 5 x square plus 5x plus 26 equal to 0. Now we have a simple two factors. So solution is x minus 5 equal to 0 or x square plus 5x plus 26 equal to 0. So which mean x minus 5 is equal to 0 mean x equal to 5. Then we know that x mean 2 to the power x equal to 5. Now if you want to find x, I can get the logarithm of both sides. So log 2 to the power x equal log 5. So now we know that log b to the power x or something is equal x log a b. Okay, using this one, I can write that log 2, this one, I can write as x log 10 2 is equal log 10 5. So therefore x equal to log a log 10 5 divided by log 10 2. Okay. Now one solution is that log 5 divided by log 2. That is one solution for x. Then to get the second solution, we have to go for x square plus 5x plus 26 equal to 0. Now it is very clear that it is not factorizable, and also we can check whether this quadratic equation has a solution or not. For that, we have to check the discriminant. If the discriminant is less than 0, that quadratic equation does not have a solution. So discriminant is delta is equal b square minus 4ac. Now b is here 5 square minus 4 times a is 1 times c is 26. So this is equal 25 minus 104. This is equal 79 negative. So which mean that discriminant is less than 0, which mean x does not have a real solution. That the quadratic equation does not have a real solution. So therefore only solution here is x equal log 10 5 divided by log 10 2. Okay, that's it.